All right, let's plug in our moles. We have 0.004, 0.006, 0, ignore water. All right, we're going to subtract 0.004 because that's the smaller of those two numbers. And then add it to the right-hand side. All right, this time acetic acid is our limiting reactant because it is used up, it goes to 0. So that means that since we have hydroxide, this solution is going to be slightly basic because that's what we have right here. All right, when this happens, we have 0 concentration of the acetic acid. We have 0.004 of the acetate in moles, and we can divide that by the total liters. So we have 60 plus 40, which is 100 milliliters. So let's go ahead and do that really quick. We have the concentration of acetate, 0.004 moles, divided by 0.1 liters, because 60 plus 40 is 100 milliliters. So we end up with 0.00, just kidding, 0.04, there we go, molarity. And then we know that the concentration of hydroxide is going to be the moles divided by the liters, and so we have 0.002 moles divided by the total liters, which is 0.1 liter. That gives us 1 times 10 to the negative 2 molarity. We can find the pOH by taking the negative log of that. And so the negative log of that will give us the pOH. And then pH is 14 minus the pOH. And so your pH should end up being 12. So the pH should end up being 12. That is our final answer for this last one right here. All right. Then our last step is to sketch the graph of the milliliters of NaOH added versus the pH and describe the major species at the starting point, the halfway point, and the equivalence point, and then past the equivalence point. I should point out, scrolling back up here, when you have acetic acid and hydroxide, so when your two reactants are equal, that is called your equivalence point. So I would add a note up here on E, that this is your equivalence point whenever they are equivalent. So whenever the two reactants are equivalent, they basically are both used up. So 0, 0 at the end right there. Then that's when you have to do the extra ice table. So that's the equivalence point. So it's not where they are equal. It is not where the pH is equal to 7, but it is where they are equivalent, where they're both used up. Neither one is in excess, they're both the limiting reactant. All right, so if we plot our graph right here, we have pH on the y-axis, milliliters of NaOH added on the x, and we scroll all the way back up here to A, if I can find it, when no milliliters of sodium hydroxide had been added, our pH was 2.89, and when 10 milliliters, it was 4.26. So let me go ahead and add that before I forget. So 2.89, 4.26. So 0 was 2.89, so approximately here. And then, there we go. And then at 10 milliliters, it was 4.26, so approximately here. All right, the next one, C, was 20 milliliters, and our pH for that is 4.74. So 20 milliliters had 4.74. So at 20 milliliters, we're at 4.74, so maybe up here-ish. All right, for our next one, D. So this one? I'll scroll down. So 30 milliliters had been added, and our pH was 5.22. So 30 milliliters was 5.22. So way up here. My scaling's a little off, but it's really hard to draw on an iPad with a finger. All right, 40 milliliters had been added, and our pH was 8.72. So 40 liters and And then at 50 milliliters, I believe we skipped 50 milliliters. Yes, we did. And so at 60 milliliters, which is way past the equivalence point, was a pH of 12. And so when we connect the dots, make sure you're connecting the dots in an S shape. And so because it's a weak acid, it's going to kind of do this curve at the beginning. It slowly goes up into this S shape, it shoots up, and then it plateaus out. So a couple characteristics. A curve is indicating that it's weak, and it's in the lower pH, so it's a weak acid. A flat plateau line indicates that it's strong, and because the pH is greater than 7, it's a strong base, which makes sense because we had acetic acid, which is a weak acid, and we had sodium hydroxide, which is a strong base. This part right here is your buffer region. Right, and so that part right there, the buffer region, it just resists the change in pH. Specifically, the midpoint right here, where the concentration of acetic acid and the concentration of acetate were equal to each other, that is your halfway point. So this right here is called your halfway point.